The topic for today is on forces and Newton's first law. This is the first topic on dynamics. We're done with describing the motion of objects. We described them in 1D, 2D, and 3D. So we have obtained some kinematic equations, and for both 1D, 2D, for among 1D, 2D, and 3D cases. And then we describe special cases of it, for example, projectile motion, motion in a circle, uniform and accelerated motion in 1D, and so on and so forth. Now the question now becomes, what causes these types of motions? So we will start our discussion by determining the forces acting on a system of particles or on a single particle. Okay, so we will motivate it with some history. Okay, now, so here's an outline of this discussion. First, we discuss some historical significance. Why is Newton very important or very significant in the history of science? So we will discuss the question of why objects move. This is the first topic is really optional for those who are watching via YouTube. You can skip it and proceed to the next discussion, next video. So we have no issues in it. But if you really want to understand why do we have come up with these principles or your Newton's laws? Saan nanggaling yan? Or paano naisip agad yan? Or naisip ba agad yan? Actually, hindi. Feel free to watch this first video on some historical significance of Newtonian mechanics. And then second, we discuss what is force. Force is basically an interaction of two objects. So dapat may dalawang objects, ibig sabihin, para mag-interact yung dalawa, para magkaroon ng force. But we will see in the next few discussions or in the next few days that we only need to consider the effect of one force onto one object. Doon lalabas yung free body diagrams natin. But we will see in Newton's third law that forces come in pairs, and therefore it should be an interaction between two objects. Okay? Questions? And then third, we discuss Newton's first law. The other two laws of motion will be discussed tomorrow, Newton's second law, Newton's third law, and an important topic which is on free body diagrams. Okay? Are there any questions so far? May mga tanong ba? May mga tanong?
None, sir.
None. Okay. Now, so here are the objectives of this discussion. We first identify all contact and non-contact forces acting on the body. Second, we differentiate mass and weight. And then we cite examples where Newton's first law is observed, and then we define inertial frames of reference. The concept of inertial reference frames or IRF is important because not all types of motions can be studied or hindi lahat nagpo-follow ng Newton's laws. Usually mga IRF lang ang nagpo-follow niyan. If there are of course, pwede mo naman i-modify yung system mo such that you will add forces para maging consistent pa rin siya sa Newton's laws. But in general, inertial reference frames lang yung talagang valid ang Newton's first law. Okay? Questions? May tanong ba? Are there any questions? Okay. Wala naman ata. So, let's proceed. So, recall, mechanics again, in my first discussion on mechanics, again, in lecture 3, I said this before, dalawa yung tanong na importante sa mechanics. How do objects move, or what's the description of motion? And why do objects move? What causes the motion of an object? Okay, we already know, as I said in the introduction, in my introductory remarks, we already know the hows. We have described the motion mathematically. Nakapag-compute tayo ng vectors, nakapag-compute tayo ng position, velocity, and acceleration. Nahanap na natin yun for different cases. The question is, what causes this motion? You have of course, your acceleration, di ba? Force will give you acceleration. So, why do objects move? And apparently, hindi naman na yung bagong tanong na yan. Hindi na bago yung tanong na yan. Okay, again, for those who are watching on YouTube, you can stop in this particular section of the video and proceed to the next one. Because the rest of the video, of this video will focus on historical, on the history of science. So yun, babalik tayo doon. But for my class, i-discuss ko to. So this is, again, this question is not something new. It's one of the most fundamental questions that were asked even before thousands of years ago by, for example, the Greeks. Yung mga Greeks, marami ng tanong yan sa buhay. So we discuss it. Okay. Now, in a nutshell, physics is like this. May meme na lumabas N years ago. Aristotle said a bunch of stuff that was wrong. Galileo and Newton fixed things up. Then Einstein broke everything again. Now we've basically got it all worked out except for small stuff, big stuff, hot stuff, cold stuff, fast stuff, heavy stuff, dark stuff, turbulence, and the concept of time. So this is what we will be discussing today. Ano yung ibig sabihin ng part na yun ng meme? Yeah, it's from a textbook. But yeah, Aristotle said something wrong, but it became a dogma for 2,000 years, and it took a lot of time before it was corrected. Yeah, there's a reason why. I'll explain to you in a bit. Bakit ganon? So, of course, the question is, why do objects move? And maraming nang sumagot niyan. Maraming nang attempt sagutin yung tanong na yan. Of course, ngayon alam na natin, force yung sagot dyan. Pero kung Griego ka 2,000 years ago, hindi yun yung magiging sagot mo. Balikan natin si Aristotle. He has a notion called natural philosophy. Some books will say that natural philosophy is synonymous with science. Some books will say that. But ako personally, hindi ako naniniwala doon. Sobrang iba ng way of thinking nila compared to our current understanding of what science is, which is based on scientific method. Hindi pa naman uso scientific method ng time nila. Now, ganito. Aristotle has an idea of what has observations. So observe some objects and then realize by deduction na baka ganito ganito yung motion ng mga bagay-bagay. And he classified motion into 4. Natural motion, violent motion, alteration, and celestial motion. So I'll explain to you celestial motion in a bit. Natural motion is up and down motion. This is what's known as up and down motion. Sir, bakit siya tinawag na natural? Halimbawa, nag-drop ka ng bola or nag-drop ka ng bato. Saan papunta yung bato? Siyempre, pababa, di ba? So, the point here is kung saan yung natural tendency ng object, kung saan yung natural place niya, dun siya pupunta. For example, smoke. Saan papunta ang smoke? Upward, di ba? Tama? Upward.
Yes, sir.
So, ibig sabihin, ang sinasabi ng natural motion, kung saan yung natural tendency ng object, for smoke, for example, paakyat siya, then dun yung place niya dapat. Okay? Dun yung place niya. Now, on the other hand, this is important because mamaya pag-uusapan natin yung geocentric model ng konti. So, then violent motion, ano yung violent motion? It's based on push or pull motion. So, this is also known as horizontal motion. Horizontal, this is vertical motion. Vertical meaning, alam naman na ng mga Griego, no, ng mga Greeks, no, na bilog ang Earth. Misconception na sabihin na na recent lang nalaman or 15th century lang nalaman na Earth is a sphere or di naman taga-sphere pero yon. Even the ancient Greeks know na spherical ang Earth. So, meron silang konsepto na ang vertical ay papunta sa radius ng Earth, inward, radially inward or radially outward. Whereas again, violent motion here means horizontal motion, meaning kapag tinulak mo yung isang object, doon siya gagalaw. Or kapag hindi mo tinulak yung isang object, or hinila mo, or tinulak mo, or mga ganung objects, yun yung violent motion. Kasi once tanggalin mo yung pagtulak mo doon sa object, mawawala yung motion niya. Diba? Halimbawa, naghila ka ng cart, halimbawa, and that cart moves, of course, because you push it. Diba? So that's violent in a sense. Ngayon, as I said, vertical motion, natural, horizontal motion, violent. One of the questions now is, what about projectile? Remember, di ba ang projectile motion, it has both horizontal and vertical components. Tama? Naalala niyo from the previous discussion? 2 discussions ago. Di ba? Projectile motion has both vertical and horizontal components. Ngayon, how would you classify it? Even Aristotle himself, hindi niya maisip paano i-explain yung motion ng, for example, a spear that's thrown, di ba? Okay. Ngayon, so meron siyang system, meron siyang naisip na way, pero it's one of the reasons bakit dinabunk after some time. But it took a really long time. I'll explain to you why later. Now, alteration, this is basically your chemistry. It's not basically motion in our sense, but it's about changing the appearances of substances. So, for example, pag syempre nasira yung food mo or kaya nagbago yung color ng trees, ng leaves sa trees, of course, chemical reaction yan. Alam na natin chemical reaction yon. Pero sa kanya, type of motion pa rin yun. Ang tawag dun ay alteration. Now, there's also this thing called celestial motion. Apparently, iba kasi, parang merong tinatawag na terrestrial domain at saka celestial domain. Parang, ang nangyari, you have your Earth. Okay, sige. Yan, dito papasok yung geocentric model. Geocentric model. Now, di ba sabi ko kanina, may natural tendency ang mga objects. So the natural tendency depends on the type of matter it contains. Ano yung matter na yon? Syempre hindi pa yan periodic table kasi 2,000 years ago to. So you have your Earth, water, avatar, air, and fire. That's the natural tendency of objects. Bakit? Halimbawa, bato, tapos nilubog mo sa tubig. Saan papunta yung bato? Di ba sa
Ilalim,
bottom?
sir.
Sa ilalim. So it means that the tendency of the rock is to go at the innermost part of the earth, which is dito sa pinaka-sentro sa earth. And ganun din yung nangyari. So for example, since medyo fire siya or air siya, papunta siya sa taas. Okay? Now, so ang difference dito, sa celestial motion kasi, so dito papasok na yung Earth ay nasa center ng universe because siya yung pinakagitna. Tapos palabas ang palabas until such time na nasa labas na, ito na yung mga stars and planets plus sun. Yan. So, ang nangyari, it turns out na yung naiisip nila, the Earth is corruptible kasi imperfect siya. Whereas since ang planets at saka stars, nung time nila, lagi namang umiikot yan regularly, hindi yan nababago. As in, yung sun mag-rise sa east, mag-set sa west, etc. Ang nangyayari, perfect tong mga to, pare-para si motion niya anytime. And therefore, hindi to corruptible. And therefore, the motion of the heavenly bodies are not the same as the motion of the earth. Okay? Magkaiba yung model dun sa earth at saka dun sa celestial bodies. Kasi incorruptible ang celestial bodies. They have permanent motions. Okay? Questions? Naintindihan to? Tong dogma na to? Gets ba? Or is this something unfamiliar to you guys? Okay, sige. Bakit ako nag-philosophy bigla? So the motion of the heavenly bodies is not governed by the laws of the terrestrial domain. Terrestrial domain meaning the earth. Ngayon, of course, yung moon makikita mo, yung moon, di ba medyo nagbabago din naman yan. May gibbous moon, may mga ganong phases ng moon. Ang sabi nila, baka kasi malapit siya sa earth. Since malapit siya sa earth, medyo nahahawa siya ng corruption ng earth. And so, and therefore, we can say na baka medyo malapit. So, yon. So, kaya may effect konti yung Earth sa Moon. Pero other planets, for example, and stars and the Sun, they move in perfect circles and therefore, dapat incorruptible yan. Ngayon, again, you have a geocentric model and therefore the motion of the stars, how stars move shouldn't be reached by someone in Earth kasi ang tao corruptible. And therefore, motion of the bodies in Earth, they're not the same. Ngayon, maraming problema yan. Pero, kung isipin mo, Aristotle is somewhat right if you are thinking that way. Kasi yun naman talaga yung natural tendency ng object, babagsak siya. So therefore, yun yung pinaka-tendency ng isang motion, ng isang object. So in a way, it makes sense. But the question now is it right? Ngayon, of course, pwede mo sabihin, Greeks naman kasi yan. Masyado na silang, iba yung point of view nila sa life. Or iba yung point of view nila ng time na the Greeks obtained answers that are wrong. But they did something's right. Ibig sabihin, yung mga perspective nila, o paano nila nakuha yung mga ideas na to, is correct. And yun pa rin yung medyo ginagamit natin until now, which is one significant contributions of the Greeks. Or, well, strictly speaking, Aristotle. Okay. Now, after some time, ngayon, ang nangyari, syempre, after some time, di nawala yung mga Greeks, dumating yung mga Romans. Grabe, no, backtrack hundreds of or thousands of years ago tong ano na to, and then Romans converted into Christianity. You get your Middle Ages and so on. Ngayon, what happened is Aristotelian tradition and the teachings of the Catholic Church are merged. Para kasing gusto nila ng logical way na i-explain yung mga teachings si Cristo. Ngayon, dun papasok yung tinatawag na scholasticism. Naging scholastic ang idea ni Aristotle. That's one of the reasons bakit ang hirap i-debunk ng teorya ni Aristotle. Kasi it is connected to the church. And by debunking Aristotle, you are challenging the authority of the church. And that time, sobrang powerful ng simbahan ng time na yun, especially in Europe. Okay? Then, kaya, after some time, nandun na tayo sa 15th century, papasok tayo kay Galileo. Galileo is this person here. Ngayon, he's one of those who oppose Aristotle's natural philosophy. In fact, yung marami pa mga persons dyan, pero hindi ko na-discuss. Hindi naman ito yung main focus ng lecture ngayon. But the point here is marami siyang issues dun sa ideas na kumalat na lang through time. Of course, di naman nakasalanan ni Aristotle yan, pero naging dogma kasi. So, kailangan i-challenge. Ngayon, matanda na siya nung challenge niya kasi, syempre, laki ng authority ng church yung time na yun, di ba? So, he developed the first telescope. This is really significant. The first telescope is really significant because, as you will see why later. So, okay, maya na yan. So, explain ko na kung bakit importante yung telescope. Ganito, di ba? Ano na-discover niya nung ginamit yung telescope niya? Naalala niyo pa? Ano yung na-discover niya when he used his telescope? From your elementary or high school science? Di ba na-discover niya yung mga moon si Jupiter? Di ba? Ngayon, ito yung importante dito. Di ba sinasabi ng geocentric model na dapat ang Earth ang center ng universe. And all of the objects should be circling relative to Earth. Ang problema, bakit yung mga moon sa Jupiter nag-encircle? Challenge agad yon. Kasi they think na lahat dapat ng bagay umiikot sa Earth or yung mga stars fixed lang siya. Pero ito, sa Jupiter umiikot. It's a challenge to that dogma na geocentric ang model ng universe. Of course, we know that is wrong. It's now heliocentric, di ba? Ngayon, also, the difference between Aristotle and Galileo is this. Aristotle, hindi siya masyadong inisip yung mga idealized situations, but Galileo thought of that. And he thinks that, syempre, falling objects, so by common experience, yung mas mabigat na bagay, mas mabilis bumagsak. Pero this is due to frictional force or drag forces. So we know that already. Si Aristotle, syempre, yun lang naman nakikita yung observation, iko-conclude niya na heavier objects will fall faster than light objects without thinking na may mga additional forces pala na nandun or additional factors na nakaka-affect dun sa motion ng object na yun. Whereas Galileo thought of this, what if wala yung mga forces na yun? What will happen? Okay, here's the experiment. So, ang ginawa niya, may mga inclined planes siya. Inclined planes siya, like for example here. This inclined plane here, if the friction is very small, ang nangyayari, if he did this experiment, baba siya, pupunta dito, almost same height yung nagagawa ng object na to. Okay, so the initial height and the final height reached by this ball here is almost the same. And then further, if you use the same, edi gagalaw, almost same pa rin. Now what if this initial position, pinabayaan ko lang tapos walang final height dyan. Walang final height dyan. What will happen? Ano mangyayari? What will happen? Since there is no such thing as the final position here, ano nangyayari? What happens is that this object will move indefinitely in time. Hindi yan hihinto. Diba? And therefore, doon niya na-realize na, okay, if this object here is moving indefinitely, dapat merong magpatigil sa kanya. And we know that since friction is present, doon humihinto yung object. But if there is no friction, an object will stay in motion pag pinasimulan mo siyang pagalawin. And therefore, so of course, you know that's your inertia, the tendency of an object. Right? Gets? So yun, the point here is, pag walang forces dyan, if this is an ideal situation, the object will still move, it will still move indefinitely. Kasi pinasimulan mo na siyang, it starts moving. And unless there is another force that will counteract that motion, the object will move indefinitely. Okay? Nakuha? Nakuha to? Nakuha tong idea
Yes,
na to?
sir.
Yes, sir.
Okay. That's the thing of... so the importance of Galileo is he thought ideal situations. And that ideal situations, doon niya na-realize sa special cases lang pala. Or I should say, there are other factors affecting the motion of objects that for what we observe today. Diba? Yung mga na-observe natin, these are ordinary situations, but apparently, pag in-idealize mo sila, doon lalabas yung iba-ibang factors na nakaka-apekto dun sa motion ng isang object. Okay, and hence, he concluded the following. Aristotle's idea have mistakes, or it's problematic because of the following. first, again, as I said, yung mga moon si Jupiter na-discover. And it contradicted the idea that the Earth is the center of the universe. Kaya sobrang bentang-benta sa church yan, yung geocentric model. Because since God created us, dapat nasa sentro tayo ng universe, geometrically. Naging literal lang nga yung translation kasi naging geometric center kasi created tayo ng Diyos, di ba? And we're special. So kaya bentang-benta yun. Pero apparently, Jupiter's moons, hindi siya nag-follow ng ganong idea. Okay? Now, for second is it's not universal. As I said, iba yung dynamics ng objects sa Earth, iba yung dynamics sa mga nasa celestial domain or ng mga planets, stars, and galaxies. Wala pang galaxy nung time na yun. Planets and stars and the sun. Okay? And then, the third idea is it's that Aristotle's ideas are deductive. Ibig sabihin, based on the observation, he concluded by deduction na okay, ito yung observation. Whereas Galileo used experiments, therefore it's inductive to formulate some hypotheses on the motion of objects. Fourth, again, there's an issue with projectile motion. Wala na kasi tayong time, so hindi ko ma-explain to. Pero the issue here is that yung sinasuggest na way ni Aristotle on projectile motion, hindi talaga siya nag-make sense. Para kasi meron kang, albawa, project sphere. So, may hangin daw dito na tutulak sa, ganyan explanation niya eh, may hangin na tutulak dun sa the sphere. So, may hangin na dadaan dito, tutulakin niya to. Kaya ang problema, paano pag dalawang pointed objects yan? Dalawang pointed to, pointed yan. Eh di wala nang itutulak dito kasi pointed din to, di ba? Yun. Isa sa mga pinakamadaling i-debunk sa projectile kasi hindi talaga siya nag-make sense. And then letter E, again, Aristotle only thought of real situations and not the ideal. And it turns out na importante yung ideal situation dito. Okay? So yon. And apparently, nung pinablish ni Galileo yung work niya, well, he was persecuted by the church. We know that. We know what happened. Kinulong siya, I think, until his death. Tama ba? Please correct me if I'm wrong. Pero if I remember correctly, he was persecuted. And nung namatay siya, a few months after, you have your Isaac Newton, which is one of the greatest scientists of the world for all time, diba? Isa sa mga GOAT yan, So, Isaac Newton is a Lucasian professor of mathematics. He's the second Lucasian professor of mathematics at the Cambridge University. And then he developed calculus independently with Leibniz. There's an interesting story on this. Basta they're not okay. Basta maganda yung kwento tungkol dito kasi they independently develop calculus tapos ayaw nilang i-reveal yung kanilang mga results. So, kasi ngayon, madali na lang peer review na yung ginagawa ngayon kaya alam natin kung sino yung unang naka-discover and so on. Pero nga, until now, issue pa rin to or they're still subject to a debate. Sino ba talagang naunang maka-discover ng Math 21 ninyo? Joke lang. Okay. Then, he first formulated his Newton's laws, but after some time, his Newton's law of gravitation needed for, I think, matagal niyang in-stop kasi hindi niya maintindihan yung ideas. So nagpunta muna siya sa optics and he developed some ideas on optics. For example, the discovery of indigo as a color of light, yung mga experiments on light and his idea on corpuscular theory. It will be explained to you maybe in Physics 72. Hindi ko na-explain yan. Tapos, nung nagsawa na siya sa optics, bumalik siya sa mechanics. And finally, he discovered the universal law of gravitation. So yun. He need to develop calculus for the universal law of gravitation. Kailangan niya yun. And then, he has a lot of contributions to math, alchemy, and theology. In fact, mas marami siyang books sa theology kaysa sa physics. And of course, he's one of the most important pieces that he's written is your Principia Mathematica Naturalis or the mathematical principles of natural philosophy. Andun yung laws of motion and some other analysis and so on and so forth. And finally, he postulated the three laws of motion. He did not discover it. He postulated it. It's a law. Okay? Actions yan. And kapag binasa mo yung Principia, may kopya ako ng Principia. If you try reading the Principia, it doesn't look like a physics book that we know today. Mukha siyang geometry book. It's more of a geometry book rather than a physics book. Okay? So yun. So the important contribution of Newton is he postulated the three laws of motion and he developed the universal law of gravitation, which are very important ideas that we know today. Okay? Questions? Questions for this? I hope you have some interesting ideas. Di ba? Interesting na idea ni Aristotle. Kahit mali. Okay. Are there any questions for this topic?
None so far.
Ah, okay.